Search in circular linked list. Searching is the operation of traversing through the list in order to locate a specific value. So let us see how can you find if a particular value is present in a circular linked list, and if present, how to locate the particular node where that value is present. So the rule number one, whenever you want to do a search, be it a circular linked list, be it a normal linked list, doubly linked list, wherever, if you want to search, always the first thing is to check whether the list is empty. So how do you check whether the list is empty? There will be a node called head, there will be a pointer called head pointer. Head pointer will always point to the first node of your list. So if your head pointer is empty, that is if there is nothing in the head pointer, that means your list is empty. There are no nodes in the list, so you can't search anywhere. So this is the first step you have to check. If it is the case, you have to know that you can't search, there is nothing to be searched. Let us say there are some nodes in the list. So how do you search for it? So let us say this is your linked list and the values are, let's say, 51, 40 and 82. These are the values in your list. There will be a head pointer which will point to your first node. Your first node will point to second, second will point to third, and because this is a circular linked list, the last node will point back to the first node. In order to implement a search in this, the first thing is you should have a search pointer. You can call it a search pointer or a current pointer because it will always point to the current position you are during the search. So initially your search pointer should point to the head node. So some people call it current pointer. So you should initialize it to point to the head node, that is the first node in your list. So let us say you are searching for value 82. So you'll see whether your node presently it is pointing to, the search pointer is pointing to, is it holding the value you are searching for, that is 82. It is not having the value 82, it is 51. What do? You will see the next pointer of your current node and move to the node pointed by the next pointer of your current node. So you reach the second node. Now your search pointer is pointing here. Again check, 40 is not matching with 80. So this is also not the one you are searching for. Move to the one pointed by the next pointer. So now your search pointer is in the third node. Yes, the value 82 matches with that of the third node. At this point, you have two options. One is you can return the pointer which is pointing to this node, which is what you do in most of the cases, because in this case, wherever you return this pointer, they can directly access the node that is being searched for. The other option is to return a count, that is what number node did you find this value in. If that is the case, you have to maintain a variable called count. It would be 0 initially. Whenever you cross through a node, you will increment it by 1 plus 1. So this will become 1 when you cross 51, it will become 2 when you cross 40, then when you reach 82, it will become 3. So wherever you find it, you will return this count. So most cases you will be returning the pointer only because that will enable direct access to the value you are searching for. So this is how you search and find out in case the value is present in the list. What if it is not present? That is the most important case coming to a circular linked list. That is where the game changes. So what are the stop conditions? Stop conditions. So whenever you are implementing any kind of search, there will be two stop conditions. One is when you find the value. Let us say you found the value you were searching for. So you can stop there. Well and good. What if you didn't find the value? If you don't find the value, then where do you stop? So generally in a linked list, the last node will not be pointing to anything. So you can say that whenever you find a node which is having next pointer as null, you will stop. But because this is a circular linked list, the last node is also pointing back to the first node, which means you'll never find a node with a null pointer. It will always point to the next node. And you will keep going in this infinite loop if you keep searching for a null. So what is your stop condition? Your stop condition should be if you reach the head pointer, that is the head node, that is the node pointed by the head pointer. Whenever you reach the head node, you should stop search. So this is the only thing you should be careful while implementing a circular linked list. That is, whenever you don't find the searched value, you should stop whenever you reach the head node back. So what is the time and space complexity? Let us see that as well. Time complexity is order of n. because you have to search through all the nodes. And what is the space complexity? It is order of 1 because you're not using any extra space for doing this. So time complexity is order of n and space complexity is order of 1.